Welcome to the Driving the World podcast series. I'm your host, Cully Holland. Today we have Don Congdon, a corporate trainer, and we're going to be discussing encoders. Hey, Don, welcome back.
Hey, Cully, nice to be back. Third time, and then you'll be rid of me.
Third time's a charm. So, if hopefully all of our listeners have listened to part 1 and part 2, they're learning a little bit more about encoders. And after part 2, we talked about incremental. So I think obviously today we're going to talk about absolute encoders. So let's dive in. Absolute encoders, what are they and when do we want to use them?
All right. Well, as you know from the previous episode, if you listened to it, we talked about incremental encoders, and these are used primarily in speed control applications, although they can be used for positioning. Absolute encoders are targeted primarily at positioning applications. They cost more money. They're actually a little bit more delicate, but they give you some enormous advantages, and so people spend the money and they take care of them, and they allow you to do some really powerful things. So bear in mind, their main purpose is to enable the motor to turn a very specific amount to produce a specific amount of motion, often linear motion, sometimes angular motion. Let's just talk about how an absolute encoder works. An absolute encoder does not output clicks or increments like an incremental encoder. It outputs numbers. For example, if I take one of our common popular absolute encoders, it may output 4,096 different numbers in a rotation. So if I took it and I connected it up to a VFD, and I've actually done this before, you can do it. You can just plug one in and you can spin the shaft. You'll see the numbers start at 0 and they'll count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, go all the way up to the maximum value like 4,095, and then when you turn it just a little more, it goes back to 0. Those numbers are indicating the angular position of the motor shaft when the encoder is attached. Now, the kind of encoder I just told you about is what's called a single turn absolute encoder. In other words, it keeps track of just one turn, and then once you've completed that turn, the numbers start over. Now, that works for some applications. That's perfectly fine, but there are some applications you need to be able to keep track of multiple turns, and we call these multi-turn absolute encoders. They're the most expensive, most complicated, and if you take a typical one like that and rotate it, it'll count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It'll get to, say, 4,095, and you'll turn it a little further, and guess what? It'll go on to 4,096, 97, 98, and keep counting. And when you buy an absolute encoder that's multi-turn, you have to specify how many total turns it should be able to keep track of. And typically, you could find one that could keep track of, say, 4,096 turns. Well, if you have 4,096 positions within the turn and 4,096 turns total, the numbers that encoder outputs as it counts, it'll start at 0, it'll count up to more than 16 million before it will start over. And that allows you to do some pretty nice positioning over longer distances. So there are those two major types of absolute encoders, and you just pay for them based on what you want to do. When you buy an absolute encoder, you have two things you have to answer. You first of all say, do you want single turn or multi-turn? And then you say, how many positions do you want it to have and how many turns should it be able to keep track of? And that's specified as two numbers, and they're actually binary numbers. For example, if you want an encoder that has 4,096 positions in one rotation, that's called a 12-bit encoder because 2 raised to the power of 12 is 4,096. So you got to kind of think in binary with these. And if you want a multi-turn encoder that counts 4,096 positions, then you say you want a 12-bit multi-turn encoder. So it's a little bit technical, but it's not too bad. And if you want to know how many total positions you'll get on a multi-turn, just add the number of bits together, raise 2 to that power, and that tells you the numbers. So just, pull out your calculator app and do a quick calculation. And I'll mention one other thing, and then I'll be done with this topic. A lot of absolute encoders also output increments, which means they can be used for speed control as well. They'll have additional channels of information, and the VFD can use those to do precision speed control. So a really nice absolute encoder kind of gives you everything.
I mean, that's awesome. And hey, third episode, I think getting a little technical is a-okay. Maybe pique some curiosity of some of our uh, more technically sound listeners. And with the single turn and multi turn, I do love it when the names actually reflect what they do because sometimes it
Yes.
gets confusing. But single turn, you get one turn, multi turn, guess what? You get multiple turns. With the incremental encoders, we talked about some interfaces. So I'm not sure if they're the same or if they're different. So, what are the interfaces that can work with an absolute encoder?
All right. Well, absolute encoders do have some different interfaces because they're communicating different information. They're not just communicating increments. Probably the most popular absolute encoder interface standard is called the hyperface. That stands for high performance interface. It's a trademark name. SEW makes an interface of their own that is very similar to hyperface. We call it SEW-RS485. So I'm going to talk about them together because they're functionally almost identical. Hyperface is neat. It's actually two interfaces in one. There are two separate channels. One channel carries position data, and it's communicated serially in a digital format. The other is an incremental interface that gives you speed information, and it's a sine cosine interface. So hyperface is both a digital number channel and a sine cosine increment channel. And that's why hyperface is so popular because it's really versatile. So those are the ones you'll see most commonly, but I'll mention again MoviLink DDI, SEW's single cable solution. We sell motors that are MoviLink DDI capable, and they transmit multiple digital data streams over that hybrid cable. One of the data streams can be absolute positioning information and possibly increments as well. And we do sell some MoviLink DDI absolute encoders that play nice with our MoviLink DDI motors and take advantage of that single cable solution to talk to the VFD.
Awesome. And love talking about the MobiLink DDI. It's very cool. And I think a lot of our customers could use it, should use it, hopefully will use it. And with the interfaces, a little different. I'm glad we stopped and talked about it because some people could easily assume encoder and encoder, they're the same. But clearly, it's giving us a little different information, a little different data. So they interface a little differently. So we talked about the nomenclature with the incrementals in the last podcast, but let's make sure we cover it again for the absolutes. Is there anything different we should be aware of? Because the four characters seemed pretty cut and dry last time, but got to talk about it.
Yes. The nomenclature for absolute encoders is practically the same as incremental. It's still the same four characters. The first character indicates the type of encoder, the second, how it attaches to the shaft, the third, the series, and the fourth, the interface. There's just one little gotcha, unfortunately. It wouldn't be SCW if we didn't have a gotcha with nomenclature.
No, it wouldn't.
Remember I said in our last episode that incremental encoders begin with the letter E. Well, absolute encoders, at least one kind of them, begin with the letter A, which is nice. But guess what? Some absolute encoders begin with the letter E. And that is potentially a little bit confusing. So you kind of have to know what type it is to know what the E indicates. If it's an incremental encoder, it's always going to begin with E. If it's absolute, it could begin with E or A. Now here's the difference. E means it's single turn. A means it's multi-turn. So that's really simple and kind of nice. I don't know why they didn't pick a different letter for single turn, but they didn't. So we just move on. The attachment method, same thing. K is very common for cone shaft. Your series number, which could be 8, or there's also a series 0 and a series 1 currently in production. And then finally, the interface. Common example of that, hyperface, letter H. SEW-RS485 is W. MoviLink DDI is Z. So let me give you two examples. This kind of encoder you'll find in servo motors. There's the EK1H. That means single turn absolute encoder, cone shaft attachment, series 1, hyperface interface. You can have an AK1H, and it's practically the same thing except it's multi-turn. The A means it keeps track of multiple turns. Otherwise, it's the same. So the nomenclature is pretty straightforward, not that bad at all, other than that little gotcha with the E.
Well, I'm glad we do have a difference between the multi-turn and single turn, but also very glad we covered it so that if folks are seeing an E and they thought they had an absolute encoder, they know it's not necessarily a mistake and it could very possibly be one. So I think we covered a lot about absolute encoders. I think we've touched a lot of the bases. And then over the last three episodes, I feel like we've really covered encoders rather well. Is there anything else in the encoder world that we need to talk about, or do you think that's about it?
Well, of course there is, Cully. Remember, I said this is a huge can of worms, and we've got one more to talk about. I'm going to talk about a related device that really isn't an encoder, except it acts like one. It's called a resolver,
Okay.
and you've probably heard of those. Resolvers are very popular with servo motors because they're relatively inexpensive, so they're considered kind of an entry-level encoder option for a servo motor. Now, what's important to understand, resolvers do not work like encoders. They're analog devices, which means they output a voltage that indicates the position as they turn, and that voltage changes continuously. What I like to tell people is that resolvers are kind of like single turn, medium resolution absolute encoders. They give you about the same performance as one. They can only keep track of a single turn, but they have a big advantage over encoders. They're super durable and they're inexpensive. They're really just two coils, one that revolves inside the other, so you could drop one on the floor, kick it around, and it would be perfectly fine with that. Try that with a absolute encoder, you'll spend $1,000 very quickly
Ooh.
because they're pretty fragile. So resolvers are good for that. They're good in any kind of punishing application or anywhere that medium performance is fine and you're trying to save a few dollars. You do need to make sure your VFD supports resolvers. Not all of them do. Many of SEWs do, so especially our MoVC generation cabinet VFDs, they support them out of the box, so that's another nice thing about MoVC. Let me give you one example of a resolver.
Okay.
A very popular one that we incorporate in many of our servo motors, the RH1M. R stands for resolver. H is how it attaches to the shaft. 1 is the series, and M means a resolver interface, that analog interface. So the nomenclature is very consistent with encoders, easy to keep track of. And with that, I think I have wound down. That's everything.
Well, good. And I'm glad the resolver got the R. Makes sense. Pretty intuitive. And I'm super glad we didn't leave the resolver out. I'm glad we got to cover it. And over the last 3 episodes, I think we learned a lot about encoders. So, Don, thank you for your time. And it's always great seeing you.
Okay, always pleasure to be here.